All right, boys and girls, what's up? I've been helping a lot of people with this, so I figured we should probably do it together, put it on Schoology. So, look, it says graph it, and then graph the secant lines passing through this point and those points. So let me try to help you a little bit. Let's put this graph into our graphic calculator. Radical x. And that's, you can see that this is actually half of a parabola. If you think about y equals radical x, if we square both sides, you get x equals y squared. And that's how you obtain both sides of that parabola. But if you just graph y equals radical x, well, the square root gives you a positive outcome. Or this wouldn't be a function if we had a plus or minus involved. So that's why the graph turns out like that. So you can see that we're going to choose this one. But that's not really the calculus part. So let me explain to you what they want you to do here. You got a function. And there's a point on here, 4, 2. And they want you to find the secant lines through the points at 1, 6, and 7. Okay, well, we need to know, in order to find the slope, we would have to put that in and see what our y is at each of those. So the easiest way to do that is to use our graphing calculator. Look, go over here to your table. You're not going to find all those. Oh, yeah, you are. Duh. Because they're all whole numbers. Later on, you might have to use the table setting and go to ask. And if you don't know how to do that, come talk to me. It's just an easy way to find a bunch of points. But look, we know it's, what was our desired? We need 1, 6, and 7. So it's going to be 1, 2.4495. And 7, 2.6458. They do want these as decimals. Otherwise, I would just leave them as radical 1, radical 6, and radical 7. So now you've got these points. That point corresponds to that one. That point corresponds to that one. And that point corresponds to that one. Well, remember that m is just y2 minus y1 over x2 minus x1. So let's see. For this point, it would just be 1 minus 2 over 1 minus 4. Negative 1 over negative 3. That's positive 1/3. Look, that's where they got that from. Okay? For this one right here, it would be 6 minus 2 over 2.4495 minus 4. Okay, we're using this point and this point. And if you put that in your calculator, you get 0.225. And then we would do it again, running out of room. We'd do it again with this one. And that's going to be 7 minus 2 over 2.6458 minus 4 again. Of course. Nope. Yep. And that gives you that. So it wants you to use that. I'm going to clear everything now. So you might need to pause this if you're keeping up with the work, because I don't have any other option. I got to scroll. How would we use those results to estimate the slope of the tangent line at that point? Well, I don't know. We might want to pick, since this one's above it. So this one is too steep because it came from the left side. And this one is too flat. And this one's also too flat. But if you ask me, maybe the best way to estimate this is just take the estimate of the two that are closest and average them. So go 0.333 plus 0.225 divided by 2. And I hope 0.225 plus 0.333 divided by 2. I think it would take that as a good answer. If not, then I guess it wanted you to average all three of them. But we could get into which is the best way to do that. And honestly, the best way to do that it would be to pick better numbers instead of picking 1 and 6. Since we're trying to do this at the point 4 comma 2, why don't we pick 2 and 5? Okay, that would be the best way. Or even better, how about we did this? How about we did, sorry, this should be a 3 and 5. Duh. How about we do a 3.5 and a 4.5? Every time we get closer and closer, we're kind of like doing the limit process. We're getting our delta x to be smaller. It'll be a better estimate for what the tangent lines are. And that's what this is asking you to do. Move the secant lines closer to P. All right, I hope this helps. Come see me if it doesn't, and I'll help you face to face.